Welcome. In this general chemistry tutorial, we'll look at completing an equilibrium ice table. Consider the equilibrium system described by the chemical reaction below. A 2.00 liter reaction vessel was filled with 0.0760 moles O2 and 0.550 moles P2O and allowed to react at 305 Kelvin. At equilibrium, there was 0.0330 molar PO2 present. Determine the concentrations of all species and then calculate the value of Kc for this reaction. We begin our ice table by finding the initial concentrations. We're given moles of O2 as well as moles of P2O and a 2-liter reaction vessel. We'll calculate the molarity of each of these reactants. Molarity is moles over liters. So we have 0.275 molar P2O and 0.0380 molar O2. Initially, we have 0 of the product PO2. To complete the change, we do this by looking at the coefficients as well as which way the reaction is headed. Since we have initial concentrations of our reactants, the reaction proceeds to the right. So our reactant concentrations will decrease by some factor X. The product will increase. This occurs stoichiometrically. So for change, we write minus 2x for P2O. We write minus 3x for O2. The minus sign indicates that the reaction is decreasing. And for the product, it increases, so plus 4x. That then, to write the equilibrium concentrations, we add lines I plus C. So the equilibrium concentrations are 0.275 minus 2x, 0.0380 minus 3x, and 4x. Let's write the equilibrium expression. We go back to the original reaction, and equilibrium expressions are written as products over reactants. We use the coefficients as exponents. So our equilibrium expression, Kc, equals concentration of PO2 to the 4th power, all divided by concentration of P2O squared times concentration of O2 cubed. At this point, we would plug in the equilibrium concentrations, set it equal to the value of Kc, and solve for X. However, we don't have the value of Kc, so there must be another way to solve for X. If we go back to the problem, it tells us the equilibrium concentration of PO2. So we'll set that concentration equal to 4x, and X then is equal to 0.00825 molar. We use the value of X to solve for the other concentrations. So at equilibrium, we have 0.258 molar P2O and 0.0132 molar O2. Now we can use those concentrations in the equilibrium expression and solve for K. When we do that, we get a K value of 7.75.